Okay, here's the notes for solve exponential equations with the same base. So essential question, explain what to do when the bases are not the same. That should be just a period. Like example 2. So I'm giving you an example to look at so then you know what steps we're looking for on whatever we do on example 2. Okay? All right, so exponential equations is our only main idea, so write that in the left-hand column. So here's a property for exponential equations. So if b is a positive number other than 1, then b to the x power equals b to the y power if and only if x equals y. So for instance, if I give you this equation, 3 to the x equals 3 to the fifth. Well, since we have the same base, then for the two sides of the equations to be the same, then x would have to equal 5 so that both sides come out to be the same, which makes sense because any other number other than 5 for this problem would not make the two sides of the equation equal. Okay, so we're going to use that property. So basically, we have to have the same base on both sides of the equation so that then we would know that the exponents are equal to each other. Okay, so let's look at example 1. So part A, we have 2 to the x plus 3 equals to 2x power. Okay, so we see that we have the same base, 2 and 2. So once you have the same base, then this exponent has to equal this exponent. So that's what we're going to do to set our equation up so we can solve for x. We don't want to do guess and check. Okay? So once your bases are the same, then set the exponents equal to each other, and then we just solve. So then I get all the x's on one side, so I'm going to subtract x. So then I get x equals 3. Now you do want to check and just double check your works. Not that I'm going to ask you to show the work, but I am going to, I do want you to double check that you don't have any weird extraneous solutions. So if I plug in 3 for x, it's 3 plus 3. This would be 2 to the 2 times 3. So that's 2 to the 6 equals 2 to the 6. Check. Works. So x equals 3 is my final answer. Okay? You try part B. So go ahead and pause this, try part B, and then turn it back on. Okay, so in part B, we have this. Okay, so we have the same base, 5 and 5. So that means I need to set this exponent equal to this exponent. So you should have done 2x minus 1 equals x plus 3. Now solve for x. So I'm going to get x over on one side, so minus x. So x minus 1 equals 3. Add 1. So x equals 4. So double check. 5 to the 2 times 4 minus 1. We're seeing if that equals 5 to the 4 plus 3. 2 times 4 is 8, minus 1 is 7. 4 plus 3 is 7. 5 to the 7th on both sides checks. So x equals 4 is correct. Okay, so those are the easiest ones when they already give you the same base on both sides. If you have the same base on both sides, then you set the exponents equal to each other and then solve. Okay. All right, let's move on to example 2. Now notice on example 2a, the bases are not the same on both sides. I have 2 to the x plus 1 equals 4 to the x plus 3. Okay. So what we have to do then is to see if we can change the bases so that they are the same. Now typically you're going to use the smaller of the two numbers when they're whole numbers, okay? Because I can't rewrite 2 to some power to make it 4, but I can rewrite 4 to some power so that it has a base of 2. So here's what I'm trying to say. So I can rewrite 4 as 2 to the second power. So this side stays the same. And so all I'm doing is taking this 4 and changing it to 2 to the second power. And then I still have what was in the original exponent. I need to put that in parentheses like that. Okay? So if the bases are not the same, then you ask yourself, can I change one of these or both? There may be a problem where we have to change both, but can I change one of these so that it has the same base raised to a power? And I could. I could change 4 to 2 squared. And then once I did that, so what's in red is what the 4 represents, 2 squared, and then whatever was in the exponent before stays, but you need to put it in parentheses because we'll have to distribute that too. Okay? So now that the bases are the same, and I'm going to take this exponent, set it equal to this exponent, and solve. So I now have x plus 1 equals 2 times parentheses x plus 3. Now we solve. So we have to distribute first. Then I'm going to minus x over. So we get 1 equals x plus 6. And then subtract 6. So we get x equals negative 5. All right, so I'm going to check, but you're going to check back in the original. Okay, so I would do 2 to the negative 5 plus 1 equals 4 to the negative 5 plus 3. So this would be 2 to the negative 4 equals 4 to the negative 2. Okay? Now these are negative exponents. Now you could type them in your calculator and get a decimal and see if the decimal's the same, but I'm just going to switch this around because this is going to be 1 over 2 to the 4th power. Remember, a negative exponent means you move it. This will be 1 over 4 to the negative 2 power. Or I'm sorry, changes to positive 2 when you change it. And so this is 2 to the 4th power is 16. 4 to the 2nd power is 16. So 1 over 16 equals 1 over 16. This is correct. Okay, so when the bases are not the same, then you have to ask yourself, can I change one of the bases so that I have the same? And I could change 4 into 2 squared. Then once you have the same base, you can set the exponents equal to each other. Okay, so now let's look at part B. All right, so on part B, we have 3 to the x power equals 1/9 to the x plus 3 power. Okay, so these are not the same base, but I could change this space to 3 raised to some power. And how you know that is that 9 is if I did 3 squared. But since it's a fraction, then you know then it has to be just instead of squared, it has to be negative 2. The negative is what makes it a fraction. So we know that 3 squared equals 9, but this is 1 over 9. So that means I need that exponent of a negative there in front of the 2. Okay, so that's what this 1/9 is 3 to the negative 2 power. And so these are just ones you kind of got to play around with. So knowing that 3 is my base, usually if you have a prime number for the base, then you're pretty set on what it should be. Okay, so 3 should be my base, and so I know 3 squared is 9, but to make it a fraction, I have to negative 9. Okay, then everything else stays the same. So I have 3 to the x over there, and then remember this is in parentheses, was originally x plus 3 on the exponent. Now, once the bases are the same, we have a 3 and a 3, then I set this exponent equal to this exponent. So x equals negative 2, parentheses x plus 3. You got to distribute first. And now, let's see, I'll add 2x over. So 3x equals negative 6. Divide by 3 equals negative 2. Okay, so I'm just going to check back in the original. So 3 to the negative 2 power, we want to see if that equals 1/9 to the negative 2 plus 3. So remember, negative means I have 1 over 3 squared. This will be 1/9. Negative 2 plus 3 is 1, so that's just 1/9 over there. This is 1/9, so it checks. X equals negative 2 is my answer. Okay. So if you don't have the same base, then pick one or maybe both of them. So if I had, let's see here. So if I had 9 to the x plus 2 equal to 27 to the x minus 1, okay? Well, then both of these would have to be changed because I can't make 27 9 to some power because 9 to the second power is 81, so I'm already not even at 27. But I could change the 9 to 3 squared, and I could change the 27 to 3 to the third power. So there's a problem, I believe, or one or two problems on your homework where you've got to change both sides. Okay, so then you have to look at both bases and say, okay, I can't do 9 to some power to get to 27. So then 3, though, divides into both of those. So yeah, 3 squared is 9, and 3 to the third is 27. And then you continue with the problem, okay, where you would bring down parentheses x plus 2, parentheses x minus 1, and then set the exponents equal and solve. Usually the setting the exponents equal to solve is the easy part. It's just you having to figure out what your bases should be. Okay, that's it for notes. So now do a repetition and then work on your worksheet.